Hello everyone, welcome to my channel. So, in today's lecture, we are starting with one of the most important topics in engineering mathematics, which is matrices. So, matrices are not only part of like your syllabus, but they are also used everywhere, like in computer graphics, AI, Google search, and even in engineering problems as well. So, yeah, let's dive into it. Um, Firstly, the definition of a matrix. Matrix is nothing but it is like a rectangular arrangement of numbers in rows and columns. Okay, so basically matrix is nothing but a rectangular arrangement. What is rectangle? Rectangle is nothing but length and breadth. Sometimes we call it as width as well. So this is nothing but a rectangle, right? We usually represent matrix with this rectangle, but in an arrangement of numbers form. In a numbers form with rows and columns. Rows and columns we can treat it as length and width or breadth. Okay, this is the definition of matrix. Let's see the example. Okay, let's take a matrix. Name of the matrix is for everyone. I mean, for me, I have a name, right? For you, you have a name. So similarly, for matrix also we have a name. Like, let's see what I told you. Matrix is nothing but a rectangular arrangement of numbers. So I'm representing it with the numbers. So writing a numbers in this form is nothing but a matrix. Okay. Okay, so and also I mentioned you about the rows and columns, right? What are rows and columns? Representing a numbers in rows and columns. So here representing a numbers in rows and columns. So this is the row. Horizontally representation is called rows. This is like a row 1 or this is like a row 2. As of now, remember just this is the one row, this is the one row. Also representing a matrix in column way, like writing the numbers vertical form is nothing but columns. These all are columns. Okay, which means if I tell you clearly, let's take an empty matrix. Writing, we usually write numbers in this way, or we can write number in this way. Writing this vertically is possible, writing this horizontally is also a good way, right? So writing in this way, arranging the numbers in this way is nothing but a matrix. Okay, okay, now let's take this example. So here writing the numbers in, if I write this numbers in this way, even writing the numbers in this way or that way, it gives an output as matrix only. So as I told you, these is nothing but a row, right? This is a row 1 and this is a row 2. And writing vertically is nothing but a column, right? Column 1, column 2 and column 3. So how many rows over here? Row 1 and row 2. 2 rows, right? How many columns? 3 columns. So number of rows are 2, number of columns are 3. Okay, this is one thing. And the next one is, the major thing is like order of matrix. Order of matrix is nothing but, let's take a rectangle. In a rectangle we usually have length and breadth, right? We usually represent area as L into B, right? For the rectangle. And also for matrix also we have a same thing but with the other name, which means an order. In place of area we are having an order of a matrix. Area of rectangle is nothing but this. Order of matrix is nothing but this. Okay, let's take an example. Let's take this matrix. How many rows? 1 and 2. 2 rows. How many columns? 1, 2, 3. So columns are 3. Okay, order is nothing. Area is nothing but length and breadth, right? So for rectangle we usually have length and breadth, and for matrix we usually have rows and columns. So similarly, number of rows and number of columns is nothing but order of matrix, which means 2 by 3. This is nothing but an order of a matrix. Okay. Okay. Now the major concept is a types of matrix. Matrix is singular, matrices is plural. Okay, remember this. Yeah. Now in the types of matrix, the first concept is row matrix. If I tell you rows means so many rows. A row means only one row, right? Remember that. Row matrix is nothing but row means one, means only one row. So one row matrix is nothing. Only one row in a matrix is nothing but a row matrix. Only one row. Only one row in a matrix is nothing but a row matrix. Similarly, column matrix. Column matrix is also similar to row matrix. Only one column is nothing but column matrix. One column means rows may in row matrix columns might be any number. Even here we have 3, we might have 4, 5, 6, but the column row should be 1. Similarly for column, the column rows might be many but column should be 1, like this. Rows might be, we can increase, but the column should be 1. So this is column matrix. Okay, the next type is square matrix. Basically, what is square matrix? Let's take a square. Square is nothing but all sides are equal, right? But in matrix we usually have, instead of sides we have rows and columns, right? So rows should be equal to columns. So number of rows and number of columns should be equal in matrix. For example, here number of rows are 2, number of columns are 2. So this is a square matrix. Okay, so square matrix is nothing but same number of rows and columns. Okay, now the next type is diagonal matrix. Basically, if I take a square, diagonal is nothing but an opposite vertex and joining two opposite vertices, right? This is nothing but a diagonal. In the similar way, for matrix also, let's take this matrix. These elements are nothing but a diagonal these elements are nothing but a diagonal. But what is the main point in the diagonal matrix is, this is just a matrix, which means all elements are present. But the specific diagonal matrix is nothing but only diagonal elements should be present in a matrix and all the remaining elements should be zeros. If I represent a matrix like this, then only it will be identified as diagonal matrix, because there are only diagonal elements are available. All the elements are like zeros. If I give an matrix like this, there is no difference, right? This is just a matrix. If I give a matrix like this, then all the elements are zeros except the diagonal element. So this is called diagonal matrix, which means all non-diagonal elements are equal to 0. Okay, let's take a simple example. This is also diagonal matrix, which means this is a small diagonal and all the remaining elements are zeros. Okay. Now the next, identity matrix. Identity matrix is also like similar to diagonal matrix, but in the diagonal matrix we not only have one, it have like a different elements, like we might have 2, 5 and 0, 0. This is also a diagonal matrix, right? This is diagonal matrix. Okay, identity is nothing but in matrices, mathematics, identity basically represents a one number. Okay, we usually have identity law kind of like that, right? Which means a by 1 is equal to 1 by a, which represents 1. Identity is nothing but 1 in mathematics. So in the same way, in matrix, identity is nothing but a kind of diagonal, but the elements which are in the diagonal place should be 1 and 0 and 0. Then this is a identity matrix. Sorry, identity matrix. Okay, so I hope you got an idea, which means identity matrix is nothing but diagonal elements are 1, remainder 0. I showed you this example. I'll show you one more example. Let's take a big matrix, 3-row matrix. So this is the diagonal, right? So all the diagonal elements are 1s and all the remaining elements are 0s. So this is a identity matrix. Okay, yeah. The next and but not least is zero matrix. This is the last one. Zero matrix. Zero matrix is nothing but the name itself telling. Identity is nothing but the name itself telling only ones will be in the diagonal and remaining will be 0. In the same way, zero matrix is nothing but all the elements in the matrix are zeros. In this way or in this way or in any way. So these all are basically equal to 0, single 0. Okay, this is nothing but a zero matrix. Okay, so these are the different types of matrices. So what are the different types of matrices? The first one is row matrix, second one is first is row, second is column, third is square, fourth is diagonal, fifth is identity, sixth is 0. These are the 6 types of matrices. Okay, now let's move on to the most important topic, which is operations on matrices. Basically, we perform few operations on numbers, right? What are operations? They are like nothing but addition, subtraction, multiplication, division, right? So in the same way, we perform operations on matrix as well. Okay, what are the different operations that we basically perform on matrix? The first one is addition. This is like just a basic addition, like how we perform it in our numbers, like 2 plus 3 kind of. Okay, let's take two matrices. Remember, the one thing is, if we have to perform a matrix addition, the both the matrices, one matrix, let's say the name of matrix as A and that this name of matrix is B, the both matrices should be of same size, like same order. Rows, number of rows and number of columns should be equal in both, like 2, this is 2, which means like here 2, number of columns in number of rows here is 2, columns here is 2 is not the thing, like no need of square matrix. We can use 2 by 3 matrix as well, like this. If you take like this and if you take like this will be, if we add this to this, there is nothing over here, right? So let's take this as row 1 should be equal to, let's take this as row A. Rows, number of rows in A matrix should be equal to number of rows in B matrix. Number of columns in A matrix should be equal to number of columns in B matrix. If not, I'll explain you again. Okay, so let's take this matrix. Okay, and let's take other matrix. This matrix name is A and this matrix name is B. Okay, here the number of rows are 2, right? Here the number of rows are 2. Okay, now here the number of columns are 2, here the number of columns are 2, which means 2 rows are equal and 2 columns, 2 rows are equal and 2 columns are equal. Okay, which means here in this matrix rows and this matrix rows, this matrix columns and this matrix columns should be equal. I hope you got it. Let's take another example. Okay, can we perform an addition to this? Let's see. Here the number of rows are 2, number of columns are 3. Here number of rows are 2, number of columns are 2. Okay, let's check. The number of rows of A should be equal to number of rows of B. Is it equal? Yes, equal. Good. Now the number of columns of A matrix should be equal to number of columns of B matrix. Is it equal? No. So we cannot perform addition. Okay, I hope you got this. This is about how we have to perform addition, when we have to perform an addition. Okay, now let's take a simple example. First, I am taking two matrices. Let's name them as A and B, as I told you before. Similar way, the result matrix should be this. Similarly, we just have to add the first element here, 1 plus 5, 6. Next, this element with the same position element is nothing but 2 plus 6 is 8. Okay, easy. The bottom element here and then here, 10, and this element here and this element, 8 plus 4, 12. So this is nothing but the addition of A plus B. Got it? Yeah, this is nothing but a simple addition. Similarly, you can do it with the 2 by 3 matrix. Both should be 2 by 3. Okay. Okay, the output matrix should be 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 4 plus 4, 8, 5 plus 9, 14, 6 plus 5, 11. Okay, this is okay. So the task I will give you now is try this and give me an answer. 8. Okay, try this and give me an answer. Give me your answer in the comment box. Okay. Yeah. Now let's move on to the second type of operation, which is scalar multiplication. Okay. Scalar multiplication is nothing but we usually take a simple matrix. Okay. Along with it, we'll take one single number. Let's take 2. Multiplying a single digit number with the matrix is nothing but a scalar multiplication. Okay, which means it is just like a simple, but we have to multiply this single digit with all the elements, and we have to put the number in the same positions. Okay, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Got it? First 2 times 1, 2 times 2, 2 times 3, 2 times 4. Okay, so this is nothing but a scalar multiplication. Simple, right? Okay, now the third type, important type, is the matrix multiplication. As of now, we have seen addition, scalar multiplication. Specifically mentioning scalar multiplication means multiplying a single digit number with a matrix. Matrix multiplication means taking both the matrices. Taking two matrices. We have to multiply two digits, right? Then only we call it as multiplication. In the same way, we should have two matrices. But it is not similar to addition. Okay, just remember that. I'm just for now I'll explain you with a simple one. Let's take a row matrix 1 2 and the column matrix. If I explain you this, then you will get a good idea. Okay, yeah, let's take this, then I'll explain you with a big the other type of matrix. Other type in the sense 2 by 3, in that way. This is like 1 by 2 matrix, right? Which is an order, 1 row 2 columns, 1 row 2 columns. This is 2 rows 1 column, 2 by 1 matrix. Got it? Just remember, first you write this. Okay, the result will definitely come as here 1 by 2, 2 by 1, right? Take like a simple thing. Here 1, you first keep 1. Here 2 are equal, right? Just remove them. Here the column, remove it. Here the row, remove it. And then take the column from that side. Okay, just remove this column from the first matrix, row from the other matrix order, and just take column from the other matrix, row from the first matrix. So this will be the result. So your result will definitely be in 1 by 1 matrix. Okay, one times 3, 1 by 1 matrix, in the sense you'll get a 1 digit number. Okay, 1 times 3, first multiply 1 with the first element in the other matrix. 1 times 3 is 3. Now add 2 times 4, 8, which is 11. So this is the result. You got it? Take the first element, multiply it with the first element in the column, write it. Take the second element, multiply it with the second element in the column, multiply it. Then add it. That's it. You got it? If not, I'll help you with the other example. Okay, 1, 3, 3 times 1. So our result will be 1 by 1. Okay, 1 times 4. You no need to multiply this 1 to other elements. Just move on to the next element. 2 times 5. You are done with 4. 2 times 5. 10. You are done with 5. Next. 3 times 6. 18. Which means 4 plus 10 plus 18 is nothing but 32. This is the answer. This is the simple matrix multiplication, but we don't have this much simple matrix multiplications. We have like a big size matrix multiplications that I'll explain you in the further classes. Okay. So now we'll just move on to real life examples like applications. Sometimes we don't know, like in our exams they might ask you about the real life applications of the matrix. They might ask you. If you get an idea or if you remember these things, you can easily fill a like blanks, or you can easily write answers for those. Okay, basic the matrix real life examples, applications are like computer graphics. In computer graphics we usually use this matrices in the form of like rotations, scaling, 3D modeling kind of. Just remember rotations, scaling. If you write this now and you can like uh, revise it when in your before your exam, that would be better, right? We won't remember the applications at the time of like we can easily remember the addition, subtraction kind of things, but we won't remember the applications, examples, those things, right? So just make a note of this and just revise them before the exam, then that would be better. So first application is computer graphics, means we'll use in rotations, scaling, 3D modeling. The next example is Google search, which means page ranking algorithm. I think I'll explain about this in further classes in different subject. Page rank algorithm. We in page rank algorithm we basically use matrix. Google search page rank algorithm is nothing but like we usually have a website, right? If I ask a topic about photosynthesis, we usually get different uh, from one website. We'll get, let's say, Geeks for Geeks, we'll get an example, we'll get from that. And also we'll get from W3 schools, and from different websites we usually get. But the ranking should be like different. First priority should be the most viewed and most liked, that will be at the top, and the remaining will be like uh, next viewed, least viewed, in that order. So that is nothing but a page rank algorithm that is actually involved in it. So there also matrix was used. That is the next example. And the third one is engineering concepts like circuit analysis, structural analysis. Okay, in these concepts like circuit analysis, I think we have done this in our intermediate physics. There we had classes, I mean we had a concept of circuits and things, right? There also we use matrix. So these are the three examples and three applications. One is computer graphics, next one is Google search, and third one is engineering concepts. Okay, so basically this is about uh, a small intro about the matrix, and we covered like what is matrix. It is nothing but a rectangular arrangement of numbers, and we have covered order of matrix is nothing but rows, number of rows into number of columns, right? Row order is nothing but number of rows into number of columns. And we also learned different types of matrix and also basic operations of matrix. One is addition, the other one is scalar multiplication, and the other one is matrix